The James Webb Telescope has discovered something absolutely incredible. According to new observations, it has been confirmed that the atmosphere of the exoplanet K2-18b contains dimethyl sulfide DMS or dimethyl disulfide DMDS, molecules that are produced exclusively by living organisms on Earth. Experts say that this is by far the strongest evidence of extraterrestrial life we have found so far, and that the oceans of this alien water world could even be teeming with inhabitants. So, are we now on the verge of confirming the existence of aliens? And what might the life forms on K2-18b look like in detail? Be sure to stay tuned until the end to find out all the background information on this spectacular discovery. The exoplanet K2-18b, only about 124 light-years away, has been the focus of astronomical interest for some time. No wonder, since the celestial body, discovered in 2015 and about 2.6 Earth radii in size, is not only located within the habitable zone of its home system, but is also suspected of being a Hycean world. So we're dealing here with a planet covered by a global ocean and boasting a hydrogen-rich atmosphere. And while K2-18b is about 8.6 times heavier than Earth and orbits a red dwarf in the constellation Leo, it made headlines back in 2023. At that time, the James Webb Telescope had found the first signs of the sulfur compound dimethyl sulfide there, and thus uncovered a red-hot lead that was immediately discussed as a potential biosignature. And that was no coincidence, of course. Dimethyl sulfide, or DMS for short, is produced exclusively by living organisms on Earth, more precisely by marine plankton and during the decomposition of organic substances. It is responsible, among other things, for the typical smell of the sea that hits our noses when we go to the beach. However, although the initial discovery of DMS on K2-18b was undoubtedly spectacular, there was a major catch. The signal was not particularly strong and could only be detected when the data was analyzed in a very specific way. At that time, the DMS signature was identified in detail by Webb's Near-Infrared Spectrometer (NIR-SPEC) and appeared in a spectral line at a wavelength of 3.4 micrometers. But that was precisely the problem. The signal overlapped heavily with that of methane, which meant that the values of the two molecules could not ultimately be clearly separated from each other. The scientists then concluded in their models that under certain conditions, biogenic sulfur gases can indeed accumulate to detectable concentrations on such hydrogen-rich planets. But only a new investigation by the James Webb Telescope could provide clear proof that this is also the case on K2-18b. And that is exactly what has now happened. Indeed, what Webb has now found on K2-18b could go down in astronomical history as one of the greatest sensations ever. Have we found extraterrestrial life? Nikku Madhusudhan from the University of Cambridge said in advance. The first clue was exciting enough to re-examine the exoplanet with the James Webb Telescope, but this time with a different measurement. And so it came to pass that the lead author of the new study, together with his colleagues, turned to Webb's MIRI spectrometer to continue the thrilling search for biosignatures. Unlike NIR-SPEC, MIRI operates in the mid-infrared range, between 6 and 12 micrometers wavelength. And that is precisely the decisive factor, because dimethyl sulfide and several other potential biosignature gases should produce even clearer signatures in this wavelength range than in the near-infrared. And while Webb had already detected methane and CO2 in the atmosphere of K2-18b in the past, a sensational breakthrough now followed. The new spectral data actually show clear peaks in the range between 6.8 and 8 micrometers and between 9 and 11 micrometers. Comparison with the expected spectral lines for 20 different molecules then showed that these signatures must originate from dimethyl sulfide or dimethyl disulfide. Madhusudhan's team commented as follows. Our data confirm the clear presence of only two molecules, DMS and DMDS. What is even more significant, however, is the high significance of this evidence. As mentioned above, the DMS spectral signature previously found in the near-infrared was simply too weak to be statistically significant. This time, however, The probability that the spectral signature is actually attributable to dimethyl sulfide or dimethyl disulfide is 3.2 standard deviations. For the presence of either DMS or DMDS, it is also around 3 sigma. This means that the probability of the spectral peaks being mere coincidences or measurement errors is 0.3%. Or, to put it another way, we now know of an exoplanet that is 99.7% composed of one or more gases that are produced exclusively by living organisms on Earth. Madhusudhan classified this exciting discovery as follows. The signal was strong and clear. We now have independent evidence using a different measuring instrument than before and in a different wavelength range of light. Our results provide new independent evidence for a possible biosignature on K2-18b. Consequently, the new measurement results provide strong evidence that extraterrestrial life could indeed exist on the nearby water world. Furthermore, the intensity of the spectral signature also indicates a high concentration of potentially biogenic molecules in the planet's atmosphere. The bottom line is that this concentration is over 10 parts per million, which is about 1,000 times higher than the corresponding value in Earth's atmosphere. K2-18b could be teeming with life. Madhusudhan explains. These quantities indicate very strong biological activity on the planet. This is consistent with what has been predicted for such Hycean worlds, and that is exactly what we have now observed. Given what we know about this planet so far, the ocean of this water world could be teeming with life. But what does all this actually mean? Has the oldest question of mankind, whether we are really alone in the universe, finally been answered with a resounding no? Are astronomers already popping champagne corks to celebrate what may be the greatest discovery of all time? Well, we're not quite there yet. Despite all the potential biosignatures, experts are currently urging caution. In fact, further steps are needed to confirm beyond doubt the existence of our long-hidden contemporaries. The lead scientist emphasizes that it is generally ill-advised to rely on one-off measurements, saying, "It's important that we remain deeply skeptical of our own results. Only through repeated verification can we reach the point where we are certain. That's how science works." Furthermore, science also works in such a way that an observation is only considered an official discovery once it reaches or exceeds a significance level of 5 sigma. In other words, this means that the probability that the results are based on pure chance must be no more than 0.00006%. But at the same time, and this is the exciting part, this hurdle could be cleared quite soon. In fact, the required significance could already be achieved by observing a few more transits of K2-18b in front of its parent star. This would only require about 8 to 24 hours of additional observation time with the James Webb Telescope. Beyond our curious infrared gaze into space, however, other theoretical and experimental analyses are needed to settle the question of life on K2-18b once and for all. As mentioned above, DMS and DMDS on our blue home planet are exclusively attributable to organisms. We simply do not know of any abiotic synthesis pathway by which these molecules are formed. But, better safe than sorry. Scientists are currently investigating whether there could be abiotic formation pathways for these gases. After all, astronomers have already conducted initial investigations into this, but so far without success. The researchers have not yet been able to find a chemical reaction that could form these molecules without the involvement of organisms. However, this does not mean that it is categorically impossible. After all, it's theoretically possible that the corresponding reaction could be discovered in the future. Why some experts are skeptical. But if this does not happen, and the biosignature of K2-18b is confirmed instead, it would be nothing less than a groundbreaking sensation and an absolute milestone in astronomy. And perhaps we are all about to witness a momentous turning point. For thousands of years, humanity has gazed at the star-studded night sky and wondered whether Earth is truly the only celestial body in the universe to have spawned life. Our ancestors associated the mysterious sparkling formations of the cosmos with their gods and attributed mythical meanings to them. And now, we may finally have unlocked the secret of life in the universe. Madhusudan also knows what a historic discovery he and his colleagues may have made. He says, "Decades from now, we may look back on this moment and see that it was decisive. This could be the turning point when the fundamental question of whether we are alone in the universe can suddenly be answered." But assuming that all these optimistic assessments are correct, what would the inhabitants of K2-18b look like? Could it be that multicellular organisms or even intelligent life have already flourished there? Is it possible that the water world is inhabited by aliens who are technologically far superior to us? Well, assuming that life is confirmed, only the future can tell. The scientist says, we cannot answer that question at this stage. The basic assumption is simple: microbial life. But even that would provide us with proof that there are other planets in the universe besides Earth that have paved the way for life to develop. However, the whole truth is that the scientific team's findings have not been met with unanimous approval among the rest of the scientific community. David Kipping, an astronomer and professor at Columbia University in New York, referred to a study from last year and stated that DMS also exists on comets. Even more sobering are the findings of another U.S. research group, which recently provided an alternative explanation for the high concentration of dimethyl sulfide. The researchers argue that K2-18b may not be a water planet at all, but instead a gigantic rock colossus with a scorching hot magma ocean and a dense, acrid hydrogen atmosphere. And that would make the emergence of life somewhat more complicated, to put it mildly. Fortunately, clicking on the subscribe button is very straightforward. Join our community now and never miss another video from us again. We'll see you soon.